Good afternoon. I'm Daniel. Welcome to the third or fourth microservices meetup in Barcelona. I work in Shipstead in the infrastructure team, and we are quite happy to sponsor this meetup. So, making all this possible and helping the team make this happen, and also having some snacks and free beer afterwards. So that's really cool, and we're quite happy that Shipstead sponsors these kind of events, because we, at Shipstead, we're quite excited about infrastructure, about microservices, and about build pipelines. So that's pretty cool. And I just introduce Gart here. Say hi.
Hello.
Yeah, good. And basically, the idea is to have like an hour or maybe a bit less about deployment pipelines with the Spinnaker, and we're quite excited about that. So I think that there's an announcement at the end, so we can start with the presentation and we'll get going.
Yeah.
Thank you. Okay, just low and high, raise your voice a bit.
Yeah.
Like I did.
Okay, welcome. Today I'll be talking about streamlining deployment in a large organization with Spinnaker. This is the longest title I've ever had for a speak. Spinnaker is a system developed by Netflix, Google, Microsoft, Cloud Foundry, Kenson Media, and also contributions from Shipstead and other people in the community. It's open source, so everybody can contribute to this project. So my name is Gard Rimestad. I'm 32 years old. I come from Norway. I'm married and have 3 children, so I have a lot to do except Spinnaker. I work in Shipstead for the infrastructure platform delivery team. We have got many platform teams, so this is one of them. I'm on GitHub as Gard Leopard, and you can email me at gardrimestad@shipstead.com. In my spare time, I like to do quadcopters, photography, computers, sports, and 3D printer stuff. So pretty much everything that a geek should do. So my team, currently we are 3 people in the team, but Anders, who's here somewhere, is joining our team pretty soon. And it's an awesome team working with delivery stuff in Shipstead. And we're doing builds with Travis, so our team is responsible for our Travis service. And we are doing bakes. Bakes is building containers or images for Amazon and that kind of stuff. So it's to get the environment for the artifact or Java application that you're building. And we have store, and that's artifact storage, Debian package storage, RPMs, NPM packages, everything related to artifact storage. And we have delivery, and that's what we are trying to solve with Spinnaker right now. It's the combination of all these tools in order to deploy it to the test environments and production environments. So I'm having a little disclaimer here. It's currently we are working in AWS very much. So our experiences with Spinnaker is only AWS so far, but we are going to move on to work with Docker and that kind of stuff when we've got the basics in AWS covered inside Shipstead. All the concepts I'm telling about will be the same for Docker as for running in AWS. It's the same strategies and way to work with builds and bakes and all this. So first off, I will define what the pipeline is to us. So you have the build step, that's building your application. maybe it's a Java application and it produces a jar file or a WAR file. And then you need to have somewhere to run it, and that's the bake stage where you put it into a container or an image for AVS. And then it's ready to be deployed to your test account or your test environment. And then you can optionally run integration tests or performance tests and do manual verification to promote it to production. And then you deploy it to production. So that's what the pipeline is in its simplest form. Oh. So I just want to put some pressure on the deployment part, because when doing pipelines, it's really important that you have a deployment system that you can absolutely trust 100%. If you're not sure that the entire cluster is upgraded and that it was successful, or if it failed, you can't really do continuous delivery. So Spinnaker, all the integrations in Spinnaker are doing this. They are really sure that the deployment works before they are giving you the feedback that it's done. And it's important to have strategies for rollback that are effective so that you're not afraid to roll back your mistakes. And you should do small changes, only a few changes at a time, every time you deploy. Deploy every push to Git instead of chunking them up to big releases. And everything should be automated, and you should never have downtime on your deployments. If you have downtime, you can obviously not deploy all day long. Oh. Yeah, so let's look at the simple pipeline. This is the simplest kind of pipeline you can have in AVS. You're building your application, you're baking it, you deploy it to your test environment, and then you run some tests and you verify it for production. And this kind of simple pipelines can be solved by any tool out there. If you've got a small team, a small organization with only a few developers, you can do this with Bamboo or Jenkins or GoCD, because on a small scale, that's enough. But if you want to scale up, you need to have something that lets you leverage from all the effort you put into your pipeline. So why we choose Spinnaker is because Spinnaker lets you compose your pipelines, and it's concentrated around and designed around your pipelines, and lets you integrate various tools into your pipeline. So Spinnaker is not doing the builds for you. You can do that with Travis or any build system. So you're using the right tool for the right job, and Spinnaker just controls this. And if you're working in a big organization, you might have several parts of your infrastructure that's following conventions inside the company, or for instance, centralized logging. In Schibsted, we use Sumo Logic, and there's no need for every team to set up Sumo Logic and configure everything and make it work. So by using something like Spinnaker, it's possible to share all these components, and it's much harder if you do it in tools like Jenkins or Bamboo and this kind of stuff. In Schibsted, we have a security team that might want to do something with our base images to make them secure and maybe trace some stuff and that kind of stuff. And in Spinnaker, we can build our stuff upon the secure base images in an easy way. And also, we want to support multiple runtime environments. Currently, we are running in AVS, as I told you, but if we have a Mesos cluster up and running, we want to be able to use the same flow to come out in Mesos. and deploy to Mesos. And with Spinnaker, you can do this quite easily and have a controlled migration to something like Mesos or Kubernetes or whatever you'd like to use. Oh, this does not look good on this screen. There's colors. But yeah, you can see that there's 8 services here in Spinnaker. Spinnaker is more like a microservice platform for handling deployments. It's not a one single binary you run. So on the top, you have deck. That's the front end. And this is a Node.js application that talks to all the APIs, or the gate API in Spinnaker, and just uses JSON to push and pull information from Spinnaker. So this means that everything you can do in the user interface can be programmed, done by code. You can just push JSON into Spinnaker, post or put, yeah, and do the configuration automatically. We got Eiger on the left, and that's the component that integrates with stuff like Jenkins and GitHub and Stash for triggering events in the pipelines in Spinnaker. So if there's been a Jenkins job, it sends this job into the Echo service, and you can subscribe to this job in Spinnaker and trigger pipelines based on successful builds and that kind of stuff. Orca is the orchestration engine. It sits in the middle and talks to the different components and routes traffic and triggers deployments and that kind of stuff. And front 50 is the component where you store your pipelines. Cloud driver on the right here is the component that talks to the different cloud providers. And Roscoe and Rush. Roscoe is the bake service, and Rush is a script execution service. So besides its own 8 components or services in Spinnaker, it depends on Cassandra and Redis for storage. It supports AWS, Google Cloud, Kubernetes, Cloud Foundry, Azure, and Titus. And you're free to add stuff like Mesos if you'd like to, and do pull requests to Spinnaker. So we expect to do that for Mesos. I think it's Titus.
Oh, okay.
Yeah. Okay. So yeah, the other integrations is, like I mentioned, the Jenkins integration that lets you subscribe to builds in Jenkins, and also lets you trigger stuff in Jenkins. GitHub, it pulls commit information and all these kind of things from GitHub or Stash. And you can also use webhooks to inject events directly into the Echo service, so that you can have custom services pushing events through webhooks and trigger stuff in your pipelines. So now I'd like to show you how this actually looks and how it works. So we've been quickly through the different parts of Spinnaker, and now we can look at how it works. Here you can see that I'm in the infrastructure platform delivery project on the top. And here you've got the list of our applications. So none of these applications was set up by Spinnaker. It was set up by Asgard, or using Asgard. So Spinnaker is compatible with Asgard. So if you're running Asgard already, Spinnaker will pick up the same stuff that Asgard does and make the transition really easy. So this list of applications are actually the real list of applications that we have, and it just popped up. And below this, we have our different pipelines. So here we have a test pipeline, a production pipeline, and a production rollback pipeline. So this page is actually like what belongs to the delivery team, and what services do we have, and what pipelines do we have in Spinnaker. So it gives you an overview of your entire team's code or services that are running. And you can see the state on the different applications. So now I've triggered a pipeline. Now we can see the colors here. So I've triggered a pipeline in, I triggered lots. A build is finished, so it triggers the deployment pipeline. So yeah, we can see the arrows and everything now. So now it's in the bake stage. The bake stage is currently running, and this has extracted the artifact from the Jenkins job, and then it starts a bake of AMI for running in Amazon, and that's currently running. So we have a link where we can see the current status of this build. We can see what's happening in the build log. So currently it's creating the AMI. It's done packaging everything. It's sending the call to AVS to actually expose the AMI to our account. So the next stage is to deploy this service to our AVS account, to our test environment. And this will happen as soon as the bake is done. And when the deployment is done, we'll trigger two jobs: this integration test stage and this performance test stage. And if you notice the arrows here, you can see that it will fan out when the deployment is done and run these two stages in parallel, so that you'd run the integration test and the performance test against the environment at the same time. And when that's done, we'll get to the manual judgment stage. And that's where the developer or product owner says that this code is ready for production. So when this has been manually verified, we can look at this pipeline. This is the production pipeline. And this one subscribes to the test environment pipeline. You can see here that this has an automated trigger, and that's the hello world test pipeline. And we say that based on successful runs of the test pipeline, we will start deploying to production. The first thing that happens when this pipeline is triggered is that we must find what AMI that we are running in the test environment. So basically, we specify what account the test cluster is running in, what region, and we select the cluster that we are using. And then we say that the newest server group, the AMI running in the newest server group for this application, is the one we want to deploy to production. So this means we are reusing the same AMI that we have tested in our test environment when we are deploying to production. And that's nice. So this production deployment depends on find images. This means that it's started after find image is finished, and it deploys to our production cluster. So when deploying with Spinnaker, you can choose from many deployment strategies, and you can create your own strategies. So we can have a look and see what strategy we are using. It's the red-black strategy, and we also have the Highlander strategy. It's a nice strategy, and we have a none, and that just creates the next server group and doesn't care about the others. And we can create our own strategies, the custom ones. And we can do a rolling push. So this means that you replace the running server group with the new AMI. So we are using the red-black because this launches the new server group, puts it into load, and then removes the load from the old server group, but keeps it there. And then you can choose how many server groups you want to keep. The lowest amount is 2, because you have the running one and the old one. And after the deployment, it will delete the third one, the old. And you can change many things in this. So for a production deployment, you might want different instance types than you have in your test environment, for instance. So you can choose this in the deployment. Okay. So let's have a look at where we're at with our pipelines now. So our bake is finished. It took 2 minutes and 31 seconds to bake this image. And now it's deploying it to our test environment. And it's done deploying, actually. And it's done shrinking the cluster. It has removed the old server group. But it's currently disabling. It's done disabling the old server group as well. So now it's triggering the integration and performance tests. So here we can see that the performance test and integration tests are blue. This means they are running. So I suspect that the performance test and integration tests soon will be done, so we can move on to the verification. Let's see. Oh, one of them are done. The integration tests are faster than the performance test. That's really nice. So we can see that every step here is green except the performance step now, performance test. I think it's some seconds left on that test. There, it's done. So now I have the manual judgment. It's not clear on the colors here, but when you have a proper screen, you'll see that this is orange or something. It's not red, and it's not blue, and it's not green. It's a different color. So when we are here, we can actually do the manual judgment. And then you can choose to stop, not deploy this to production, or we can choose to continue and deploy this to production. So let's see what's happening now. Here we have the production pipeline. And it's starting. The find image stage is done already because it's only looking up what image is running in our dev environment and extracting the AMI. So it started to do the deployment to our production environment. So right now, while we've been talking, this has been deployed to production. And of course, if you trust your tests and that kind of stuff, you don't need to have a manual step. So it depends on how much you trust your tests.
Completely.
Yeah. In this project, I could trust my tests. They're pretty good. They never fail. So they're just sleeping. Okay. So now we've seen that. I can show you how the rollback works as well. There are several ways. We could have created strategy for rollback, but in this example, we've just done it manually. So based on nothing, it's no triggers. This is only a manual trigger for this rollback. You can automate it, of course, if some tests are failing in production, automatically roll back. But this example, there's no automated trigger. So if you launch it, it will the first thing it will do is enable a server group, and it's taking the previous server group, the old server group, enabling it, giving it load, and when that's done, it disables the newest server group. So this is a rollback. You can do it, you can automate it and trace who's doing it. Yes. So yeah, here you can see what's happening. It's currently deploying to production. It just disabled this previous version of production, so I guess the deployment of production is soon to be done. Yeah, it's done deploying to production. It's shrinking the cluster and disabling the old cluster. So we've had a successful deployment to production. So it's probably time to do a rollback soon. For all tasks, you can see what's happening. So now I've drilled down to the disable cluster, and you can see that it's doing the last part, the force cache refresh. So it's probably just waiting for the cloud driver to refresh the state of the cluster. And for all steps, you can see the details. Determine source server group, create server group, monitor, deploy, cache refresh, and all this stuff. So you can really dive into every detail of every step that's happening in your pipeline. Come on. Still running. Okay. Is it done? I think we can start the rollback now and just continue the presentation, and we can see what happens in the rollback. Yeah, it's done. Perfect. So when we look at this now, we should see that this version 10 of our application becomes active. And when it's active, we should see that the version 11 becomes inactive. Right? Start pushing load to the old generation and remove the new generation. So it's waiting for the instances to be healthy in the ELB, I guess.
It's a slow Amazon day.
Yeah. There, it's active. So the old version of production is running and receiving load. So now it will start to tear down the new generation so that it's phased out the new generation with performance issues. See? Yeah, it's starting to tear it down. So we should see pretty soon that this is removed from load. It's very exciting to see it actually happening so I have to wait. It's, you have to trust your deployment and your rollbacks. So let's see this. Yeah. So we've deployed to production and also rolled back. It's very good. So just to summarize, I love the page that you're seeing here, the team page. You can have this on a big screen in your office space and actually follow all your application and how they're behaving. You can see that there's activity in your pipelines, and yeah, it's awesome. So, okay, it worked after a little while in colors. So, we've been working a lot with the bakery in Spinnaker. It's where you create your AMIs, and it's one of the places where you really can save some time of your deployments or your delivery pipeline. It consists of two parts, like I mentioned earlier. It's a Roscoe. This is an API that enables you to do the bakes. And Rush is the actual service that runs the bakes or runs Packer or whatever you want to use. This is a very simple kind of setup. We're not using stuff like Puppet or Chef or Ansible to build our AMIs. The API lets you give a list of RPMs or Debian packages that you build your AMI with. And you can also provide a reference to an AMI so that you build upon a previously built AMI. And you can give your AMI a name. And also, internally, we have the ability to share an AMI between different Amazon accounts so that we can use the same AMI in many accounts, the same build. So what are the powers of this thing? So, like it said, we are using Debian packages or RPMs. So it's really just apt-get install or yum install this package. And it's very easy to reproduce and run lots of tests on and also optimize. So we are using a chroot builder. This is something we've contributed to Spinnaker with. We have made a pull request for it, and they've accepted it. So this shaves off about 3 minutes of build time using chroot instead of EBS builders. And we also are able to do layered bakes or incremental bakes. And I'll get more into details about these things now. So the chroot builder is not launching an Amazon instance to do the bake or build an AMI. It's an instance already running that just mounts the AMI you're basing your build upon, and then chroots into this mount point, and does whatever you want to do with your to build your application AMI inside it. And this means that you don't boot the instance, and you save about 3 minutes. And after it's done with that, it tags the snapshot and shares the AMI in Amazon so you can use it. Layered bakes is enabling us to, there are some packages that takes a long time to install, like JDKs, doing system upgrades, and also we have conventions for logging and metrics. So this means we can build a JDK base image with security patches, JDK, log setup, and metrics, and build upon that so that when you're building your AMI for your application, you're just pulling down the jar file itself and your configuration that is related to your application. And this means that we can save very much time on building because we are not always installing the JDK and patches and this stuff. We also contributed to Spinnaker with an upgrade flag to the bakery. And this means that you can actually build an AMI for your application, and every time you do a new bake, you don't actually actually install anything. You just upgrade the packages on the system. So this is more like an incremental build in Gradle or whatever, just for AMIs. This also saves a lot of time. So for one of the applications we are developing with EBS builder, it took about 13 minutes to build the application, or the AMI for the application. With only changing from EBS-backed baking to CH root, we got down to 9 minutes. And doing layered bakes, where we have all the dependencies installed before we install the actual application, we were down to 3 minutes. So it means we are saving a lot of time by doing these optimizations. And this stuff is something the entire company can leverage from. Everybody can use our base image with JDK, with logging and monitoring set up already. So they only need to concern about their application and that RPM or Debian package. And they can have insanely fast bakes. So what about Docker? If you're creating an application with an RPM or Debian package that only depends on having a JDK installed or something like that, it's easy to use the same Debian or RPM package that you're using in the Amazon bakery to build a Docker image or Docker container. So in Spinnaker, you're able to fan out, like we saw on the integration test and performance test in the demo. And this means that you can actually build your RPM or Debian package and then start a bake of an AMI for Amazon and Docker image for running in Mesos or whatever. And you can easily work with both of them at the same time, and it doesn't take you any longer than using only one. Yeah. So let's talk a little bit about the actual stuff in Spinnaker with pipeline orchestration. So you can actually make templates of pipelines, so that when you have a new application, you can just copy the template and maybe change a property or two, and it's ready. You have a working pipeline for production and test environments and everything. So it lets you reuse what you've already created. You can chain pipelines together to share stuff like base AMIs, or to do like we did with the production deployment, that when you have a green test environment pipeline with the manual verification, it will trigger the production deployment. Yeah, and that's this promotion between environments and stages, yeah. And you can choose from many various deployment strategies and create your own strategies. And you also can get notifications in Slack or HipChat or mail or whatnot. So in Spinnaker, we've seen that I had the project, that was my team, and you could see every application that belonged to my team. And this is an attempt to illustrate how this actually works inside Spinnaker. So at the top, you have the project. One project can own one or more application. And an application is like in Spinnaker, if you had Spinnaker inside Spinnaker, you would call Spinnaker one application. And as we saw earlier, Spinnaker consists of 8 services, and that would be 8 different clusters beneath Spinnaker. So one application can consist of many services. And one cluster for one service is represented by a cluster, and that cluster can have several server groups. In the rollback example, we had just one server group for the new generation of the service and one for the old one. But you can also have several server groups, like one in EU West, one in US East, and that kind of stuff. Okay, now I'll talk a little bit about the experience we have had with Spinnaker so far. How it was to set it up, how it was to contribute, and how the community is. So setting up Spinnaker is pretty much like setting up any service. It feels like the same thing every time I set up a new service. So it's just as good and just as bad as regular services. One important thing to notice when you're setting up Spinnaker is to read through the configuration files, because it's a lot of inheritance inside the configuration files, and when you read them, you get some ahas along the way. So it's important to just, when it's not working, just read the configuration files so you understand the inheritance. And it's kind of confusing with the Redis and Cassandra usage. It's more like, it feels like Cassandra is what you use for persistent storage and Redis is a cache in my head, but it feels like when working with Spinnaker, sometimes Redis is more treated like just the same as a Cassandra database. You need to rely on the storage there. So we are taking backups of our Redis clusters as well as the Cassandra clusters. Contributing. As I said before, Spinnaker is open source, so you can contribute to the code to make improvements, add features, and fix bugs. And we've done that. We've only been working with Spinnaker for some months, and already we've had 10 accepted pull requests. And it's very nice to do pull requests to Spinnaker because the people there are really encouraging you to do it and giving constructive feedback, and it's easy. It takes 24 hours to get a pull request accepted, and that's very fast compared to some of the source code bases I've contributed to before. They are responsive and they are encouraging this and working hard to make this happen. So the community, I talked a little bit about the pull request handling, that it was awesome, but it's also very nice to be in the Slack channel. If you're trying to do stuff with Spinnaker, and they have their own Slack setup, so you can just go in there, ask them questions, and you get direct contact with people who have used it a lot, or maybe the core developers, so it's awesome. You can also create issues in GitHub or ask questions in Stack Overflow. On Stack Overflow, yeah. So, here we got a blank slide. Yeah, let's go to the next one. Yeah. So, Spinnaker is a platform for continuous delivery of microservices in the cloud. So after this presentation, I hope you see that it's possible to use it for several cloud providers and several kind of technologies like Docker and that kind of stuff. And thank you for listening to me. I would like to give some kudos to the delivery team, my team. It's an awesome team. I would like to give kudos to Schibsted for letting us work on Spinnaker. It's really fun. And also the Edge team for using our tools. It's awesome. And I want to thank Natalia for setting up this awesome meetup. And thank you for listening to my talk. Yeah, I'll just do the questions first.
So can I'll put this the other slide and then we can do it.
Yeah. Okay.
To get it out of the door, do the play thing. So,
yeah.
Good. Okay. Awesome talk despite the analog problems. So just have a small announcement and then we can go to the Q&A. So if anyone has any questions, I'm sure God will be happy to answer them. Okay, I'll just kind of get this a bit far away. So basically just a teaser about that. We did a competition or like a challenge at the latest DockerCon, and we got very, very good feedback. So we're just doing another one. It was called Docker Maze, so we do another Docker Maze. I think it's coming in April. So if you stay tuned to the Meetup, the Meetup page, we'll get some more details when it's launched. And it's just a competition about Dockers. You know, just cool. We think it's cool. So and people who played with it, they actually found it cool as well. So awesome. So if anyone has any questions, I think God would be happy to answer. And I would ask you to use the microphone. Another? Oh, really? Okay. Okay, go. I don't know.
Sure?
Oh.
Oh.
Okay. So it's Docker Maze Reloaded. Okay.
Yeah, this is the real name.
Okay, that's the name of the challenge. Okay. So, okay, thank you. So if anyone has any questions, I'm sure God will be happy to answer about the Spinnaker, and then there's like some foodie and beer.
Yeah.
So, thanks for coming here, and I'm sure we can have a chat later. So I would ask you to use the microphone. So, when we put this up on the internet, it's not a monologue by Garth, but it's just actually people asking questions. So, anyone? No questions at all? No? Are you sure?
Yeah. If you want to, yeah, okay.
So we mentioned security, which is always quite important. So where do you think that we could fit in security into the pipeline? So we saw one example, a very good demo of a pipeline, which is getting a application into production and pushing a button to do it. But where do you think security could fit in? Because it was one of the features we discussed or you mentioned. But what ideas do you have?
Yeah, so the first part of security is actually upgrading the packages on the system. If you're building upon base AMI from Trusty or Amazon Linux, it often hasn't got the latest security patches. So just doing an upgrade will give you some more security than you had before. And also the security team should be involved when building the base AMIs that we will use, so that every AMI in Schibsted will have some, maybe, I don't know what the security team actually will do, but maybe it will be some tracing or some things checking for intruders or whatever. And this can be added in the base images, and every pipeline can base upon this image, and they don't know that the security team is actually there and helping them out. So, yeah.
Cool. So, any other questions? Feel free to ask. No, it's me, Garth, who answers. So I encourage you.
Yes. Okay. I'm going to risk because you had this manual approval thing in the pipeline.
Yeah.
And I can imagine that this is because you were doing some manual testing on the test environment in order to approve the release. Maybe this could be somehow automated in a different tool, like you have people that are manually testing the release, and whenever they have completed their manual test, you have all the test cases covered.
Yeah.
This could hook into the pipeline in an automatic way without having to go there and push the button.
Yeah,
So
you don't, the manual verification stage is optional. So you could do, like you say, that when they've filled out some forms or something, it's automatically done, or it's like the automatic verification is something, from my experience, you usually do the automatic rollout to production when you're in the early phases of a project. So when you're like rapidly developing your application, you automatically roll out to production. But when we start to get lots of user and stuff like that, you need really good tests in order to trust your code as good as automatically roll out. So what I've seen is that starting new project, you start with the automatic rollout, and gradually you move to have like this verification stage. Because when you have, like, if you have millions of users on your service, it's really nice to just press the button that it should go out to production, and then watch the logs and metrics and see that everything is behaving like it should. But it's not needed at all, but in my experience, people tend to like to have manual judgments before actually rolling it out when they have a lot of users. Yeah.
Thank you for the talk, first of all. So I have a question about practicality. Do you think it makes sense to actually use Spinnaker for a small team of 2-3 person? And secondly, how long do you think it will take for someone that doesn't know anything about Spinnaker to get from zero to get this deployed and working in their organization?
Yeah. If you're in a small team, in a small organization with like 3 people, like you said, it's possible to use it, and your requirements won't be the same as we have in Schibsted, because if Spinnaker goes down for us, it hurts all the developers. So we need a really reliable, big, nice setup. But running Spinnaker for a team of 3 persons, it can run on 1 server or 2 servers, and it's very possible to just do that in, like, set it up in, I think, 4 days, something like that, yeah. And then you have it up and running, and it should be good enough. The requirements in a small team, like, is it going down? It's not that dangerous as in a big setup.
Also, on just one, they provide pre-built API, so it's very easy to have only one server with all the microservices running in the same server, and you can start testing it, and then you can move to a more HA reliable deployment.
Yeah. Actually, the demo instance you're looking at, not now, but you were looking at, was set up today. We used like 30 minutes or something because we've done it before, but it's easy. Kind of easy, yeah.
Hello, Gart.
Hello.
Hello. Question. So it wasn't clear for me, or maybe it's like both possibilities or either one. So like when you start new projects inside Spinnaker, do you do it like in a JSON file format where you define the whole project, or do you do it manually clicking through the UI?
Yeah. We currently have not got a JSON setup for this, but let's go inside this one. All of these projects that are here, they are set up with CloudFormations and Asgard. So this is the bake service that we are using, and I haven't done anything in Spinnaker for this service. It's just looking up in the APIs and setting up all this stuff. So creating a pipeline for this is really easy. You can just start giving it a name, and we are ready. And deployments and everything looks up the right groups and everything. So the cost of setting up a pipeline it's not that big because you're only setting up a couple of stages. But you can automate it because everything is available through an API. But in my opinion, when you're doing pipelines, it's nice to just do it like this because for every service you set up, you only do it once, and sometimes you add the stage like integration tests or whatever. But it's not a big deal to set up a pipeline.
Okay. Anyone else? Okay, one more, maybe.
In terms of dependencies, could you explain why does it depend on both Cassandra and Redis? And are there any plans to converge into one of the two?
Yeah, I'm not 100% sure of the plans, but from the back of my head, I think that the team has mentioned that they will work on making the storage stuff easier, but I'm not 100% sure. It confuses me a lot, the usage of Cassandra and Redis, because if you remember the Roscoe service, the script executor, that's using Cassandra. And Roscoe, the bake service, is using Redis. And it's strange because every request you do for logs and everything is going to the bake service that's using Redis. But the real persistent storage, in my opinion, is on the script executor. So let me just show you this.
You can easily picture two different teams doing some of the services. So it looks like that. We don't know, but it would be something as simple as having just two different teams doing some of the services involved in Spinnaker, and just kind of grabbing one tool and then just cracking on with it.
Yeah, if you look here, you can see Rush is using Cassandra. Roscoe is using Redis. Front 50 is using Cassandra. And I think this is a good choice because Cassandra is storing your pipeline definitions, and that's very good. And Cloud Driver is using Redis. It's a good thing. Cloud Driver is only talking to the cloud provider and caching the results. Orca is probably okay with the Redis here as well. So and Event Bus uses persistent storage, and that's a good thing. So the only place where I'm confused is in these two services, if it's a correct decision to use Cassandra here and Redis here. But it might be, but I'm not sure. So basically, I'm fine with all these. Yeah.
Okay. Any last questions? No. So okay.
Yeah.
One last question. Okay.
I have a funny one.
Okay. Funny ones. Welcome.
Have you ever deployed a new version of Spinnaker using Spinnaker?
It's a good question, and it's something we will do. We'll of course use Spinnaker to deploy Spinnaker, but currently we are not doing that. But we are actually building we are using Spinnaker to build all the components, but not yet deploying them. So Roscoe and Rush is building themselves. So it's like 3D printers, replicators, RepRap printers. It's the same thing. You build yourself.
Next is Skynet. So I believe we have one last question here.
Here,
So
Can
Skynet.
this replace Go CD?
Yes.
And there's more than that.
Yes. Lots more.
So, okay, so thanks very much to everyone, and especially to Gart for this awesome talk, and thanks Schibsted for the allowing us to do this and sponsoring the event and getting some free food and beer. So thanks everyone.
One little thing is that if anybody wants to look at it and click on it, so Spinnaker, you can just come here afterwards and try it on my computer. Have a look. Yeah, it's okay.